Okay. Welcome to the 2010 Ely Lecture featuring Hal Varian. Now, I've known and admired Hal Varian since I was a kid, assistant professor at Berkeley, and he was a graduate student. He sought my advice about what to study, and I said, learn McFadden. And he tells me this. I don't actually recall this encounter, but I credit it. And he tells me he learned a lot from McFadden, as we all did in those days and have ever since. But something tells me he would have learned McFadden at Berkeley in the late 1960s, even without my advice. When I was on the MIT faculty in 1973, Hal gave the most amazing and entertaining job market talk, later published in the Journal of Economic Theory, on envy. The key result, which I'm sure you all know, Theorem 2.1, is, quote, if X is a strongly efficient allocation, then there is some agent who envies no one, and there is some agent that no one envies. I thought that was an amazing result. Now, thanks to his success at Google, Hal has become the agent who envies no one, at least among economists. So Hal went on to do well, why don't you move into the middle? There's plenty of seats in the middle. I don't think we can do better. The sound system isn't great, I understand. Okay, well, Hal went on to do path-breaking academic research on generalizations of revealed preference, on information economics, and on a slew of other applied theory topics. He's exercised his talents in a remarkable range of spheres. He has to be the only economist who's ever published in Byte magazine, which is not a food magazine. He wrote wonderful, informative, and, dare I say it, non-tendentious columns for the New York Times, which contrasted nicely with those of another high-profile economist. He brought the Berkeley Library School into the 21st century, so it taught information management in place of paper management. He's the author of 2 widely used textbooks in microtheory, much influenced by that Dan McFadden, and the wonderful Information Rules. And Carl Shapiro, I'm happy to say, is here, the co-author of that wonderful book. It's a popular book that's been translated into every known human language and Klingon. Starting 7 years ago, he became a force at Google, where he's now chief economist, showing, as we all suspected but failed to demonstrate ourselves, that good economics is good business. I'm delighted to welcome Hal Varian as the 2010 Ely Lecture, speaking on computer-mediated transactions.
Well, thank you very much for that wonderful introduction. It brings back a lot of good memories for me. And I hope I'll be at least as entertaining now as in my job talk 35 years ago. So I want to talk about computer-mediated transactions, and there's a little outline here. I'm going to talk a bit about innovation, waves of innovation, and then I'll talk about the computer-mediated transactions directly, and then at the end a little bit about collaborative computing. And the general theme of the talk is this is what's happening in technology, what are the implications for commerce, what are the implications for economics. So we start out with a pretty obvious observation. There's been this huge innovation on the web and on the internet for the last 15 years. We've got web pages and search engines and wikis and docs and all sorts of other new innovations have been coming out. So why has there been so much and why has it been so rapid? And my explanation for this is that this is an example of what I like to call combinatorial innovation. So the idea there is that there's a set of component technologies that becomes available at different times in history, and then there's a wave of innovation as inventors combine and recombine those components to create new innovations. So back in the 1800s, the new set of component parts was interchangeable mechanical parts. And you may know the story of how Thomas Jefferson went to France to restock the White House, or maybe to stock the White House wine cellar. But along the way, he saw that the French munitions makers were so skilled they could build weapons that had interchangeable parts. came back to the United States and said we should set up a DARPA program to do this ourselves. The result was the Springfield Armory, where they worked on building interchangeable parts, mechanical parts, and it was the availability of those components, those off-the-shelf pulleys, wheels, gears, cams, etc., that provided the raw materials for innovators in the 19th century to build all those great innovations, the sewing machine and the washing machine and the bicycle, and then towards the end of the century, the automobile. And then around 1900, we saw gasoline engines that found their way into automobiles and tractors and pumps and motorcycles and all sorts of things, setting off another wave of innovation. Think about the Wright brothers. They took kite technology, bicycle technology, and the gasoline engine and combined those components to create a new innovation. In the 1960s, we saw integrated circuits. There must be thousands of integrated circuits in this room alone. And then in the early 90s, mid-90s and 2000s, we saw this range of combinatorial innovation surrounding the internet. Now, this is not a new idea at all. There are many other economists who've observed this kind of phenomenon. Often, this process takes years, decades, even a century in the case of interchangeable parts. But this time, we saw this huge innovation in just a few years. And I think what's different this time is the components, the component parts, they're all bits. They're all protocols and languages and software. There's TCP/IP and HTTP and HTML, all of these different kinds of non-material components. And in the bits and the protocols and the languages can be combined to make web pages and wikis and auctions and exchanges and search engines and on and on and on. So there's no time to manufacture. There's no inventory problems. There's no logistics. The bits can be shipped around the world in seconds, and you can have all of these innovators working in parallel off the same set of component parts. And so you get this very, very rapid evolution and technological progress. You never run out of HTML, just like you never run out of email. You can get as much as you want, or maybe even much more than you want. So the question I want to explore today is then, what are the implications of this kind of combinatorial innovation for commerce? And I want to start with a point which is so obvious and so mundane it hardly seems worth mentioning, but the point is there's a computer in the middle of almost every economic transaction. So between every buyer and seller, essentially, there's a computer. And it can be a very simple computer. If you go to the corner store and buy a cup of coffee, they'll ring up the sale on a computer because cash registers nowadays are just computers with a different user interface. And if you go on the web and buy something, there'll be a database involved. When you bought your ticket to fly here, you had a computer-mediated transaction using very complicated set of algorithms to determine the prices you paid. Now, that itself is an interesting story because the original reason for putting systems like Sabre together for transportation, or systems like any kind of web data warehouse, was just to do the accounting. So it's just to keep track of the transactions. But once that system is put in place, then there have been many other, perhaps surprising and unintended uses that evolved for those sorts of computer-mediated transactions. So the general story here is what are enabled by computer-mediated transactions. One, I claim, better contracts. Two, the data extraction and analysis. Three, controlled experimentation. And four, the personalization and customization. I want to spend the next half hour or so talking about these different ways that you can use that computer in the middle of the transaction to perform useful tasks. So just to review a little bit, contracts are fundamental to commerce. So the simplest contract would be, I'll do X if you do Y. And so we'd use this for exchange of goods, services, labor. If you give me $2, I'll give you a cup of coffee. Now the major problem comes in monitoring the contract, because sometimes you can directly observe the contract, you can observe what's happening, but oftentimes the quality of the goods, the services, the labor, whatever, is not directly observed, and there's a very large literature in contract theory and mechanism design that works off of this idea of what's observed, what's not observed, what's enforceable, what's not enforceable, and so on. So as an example, I gave you the contract, if you give me $2, I'll give you a cup of coffee. Well, allegedly, Abraham Lincoln was once served a beverage. He took a sip and said, "Madam, if this is coffee, please bring me tea. If this is tea, please bring me coffee." And I'm sure we've all had a similar experience at some time or another. So what happens when the computers come in? Well, they make things more observable and thus more contractible. And even though I'm talking about computer-mediated transactions, I really should be thinking in broader terms of information technology in general, because information technology has been improving, monitoring, changing transactions actually for thousands and thousands of years. So just to sort of give you a summary of what I've been saying, since the computer serves as an intermediary in these transactions, or in the middle of all these transactions, they not only can be an accountant, they can also verify contractual performance, and that allows us to structure more elaborate contracts and potentially improve economic efficiency. So the gentleman that you see on the slide is a famous accountant. You might not have known there was such a thing as a famous accountant, but this is Francesco de Marco Dattini, who made several advances in accounting in the Middle Ages. And just think what would happen if he had a computer. In fact, he could engage in accounting plus computers, gives you better monitoring and therefore potentially better contracts. So let me give you some examples. So a simplest example, just to motivate things. Think about rental cars. So what happens, suppose, since we're an economist, we have to make some assumptions. Suppose insurance for rental cars would cost less if people drove more slowly. That's assumption one. Drivers might be willing to drive more slowly. If they paid less for the rental car, they might agree to that choice, but the contract can't be made because the speed of operation isn't observed. So you end up with this inefficiency where, yes, you sign the contract that says you'll operate the car safely, and then you peel out of the driveway never to be seen again. But now, of course, you can enforce these contracts. You just put a computer in the trunk of the car. The computer monitors the vehicular system, and then you can commit to paying a certain rate if you operate the car in a certain way. The contract becomes feasible, and in this very, very simple example, everybody's made better off. So you get a Pareto improvement. Now, that wouldn't happen in general. If you had heterogeneous tastes, it might be that some people who had a very strong taste for speeding wouldn't really want to do this, but if enough people wanted to sign the contract, you would have a kind of selection problem that would force you into a solution that was better overall in some sense, but not necessarily better for every party. But that's the kind of thing I'm thinking about. You have a contract previously infeasible, you bring in some information technology that proves the monitoring, and then you end up with a more efficient contract. So I want to give a few examples of this. And I'm going to start at the beginning, 3,300 BC. Might as well get there early. And then talk about cash registers in the 1880s, semi-trucks in the 80s, video stores in the 90s, and online advertising in the 2000s. I don't really mean to imply that online advertising is the culmination of 5,000 years of economic activity, but it's just something I've learned a little about and thought it'd be nice to share it with you today. All right, well, let's talk about the Mediterranean shipping, which is, I think, really just a wonderful example. It's about the problem of how do you ensure that your shipment is received at the other end of the voyage when there's no written language and there's no, people are illiterate and innumerate. There are no numbers and there's no letters. So what they did is they had this very, very clever solution of these little clay tokens known as bullae, and there's a couple pictures of them over there. They were tokens that were shaped like the item that was being shipped. So you might have a amphora of olive oil, or you might have a sheepskin. That's what those two bullae are that you see on the screen. And then the harbor master, each time a barrel of oil was loaded onto the ship, the harbor master would move a token from one side of the accounting desk to the other, and then when they're all loaded on the ship, those were sealed up in an envelope and stamped with a special official seal. It was baked in an oven, given to the captain. The captain delivered the cargo the other end of the voyage. They took off the envelope, broke it open, and every time a barrel of oil was unloaded, they moved the token from one side of the counter to the other. So you're able to verify that the tokens were in one-to-one correspondence with the shipment, and the contract was then completed. So adding this little bit of information technology, very, very trivial kind of information technology, allowed you to, in fact, carry out transactions that otherwise would have been totally infeasible. And in fact, if you go look at the archaeology museums, every shipwreck in the Mediterranean from this period has a set of bullae in it, and many scholars believe that this is what led to writing, because subsequently they would inscribe marks on the outside of the clay to indicate how many tokens were supposed to be inside, and then they said, well, gee, we've got the marks, we've got the clay, do we really need the tokens? And that was the invention of writing in numbers. So I think it's a very important story in human history. Now skip forward a few thousand years. Oh, there's some examples of bullae that were used in that period. So skip forward a few thousand years and think about poor Mr. James Ritty, who owned a saloon in Cincinnati and would occasionally catch his employees pilfering money out of the cash drawer. So he had a monitoring problem as well, and went to work to try to solve it. 1883, he invented a device known as the incorruptible cashier. I love the name, the incorruptible cashier. He had two innovations. One innovation was that when you opened the cash drawer, the cash register went ka-ching, and that was notice that the saloon keeper should look over and make sure that things were being on the up and up. And the other aspect was that it recorded each transaction on paper tape. At the end of the day, the owner could go through and verify that the amount of transactions on the tape were supposed to be in accord with the amount of money in the cash drawer. So there are some scholars that argue that this invention of the cash register was actually quite important because it allowed businesses to expand beyond just the family, and you could have strangers actually operating, holding the cash, which was something that was very difficult to do without that capability for monitoring. And then go forward a few more years. In the 1980s, we saw these vehicular monitoring systems that were put on trucks. Virtually every semi that you see driving down the road has a computer in it, and most of those computers actually connect to satellites so you can monitor the performance of the truck. It was put in place to improve logistics and shipping, but it had a very beneficial effect on honesty as well, because a common fraud had been for drivers to fill up their buddy's tank on the company credit card. Once you had a record of the mileage, that could no longer be done. So these are nice examples of how adding the technology in improved the performance of the industry. Another great example, I think, is this video store rental. So many in this audience are old enough to remember the bad old days, and the bad old days were when you walked into the video store, wanted to rent the most recent video, and what had happened? Well, the recent video, of course, had been rented by someone else. The prices were high, $60 a video. The store would buy only a few, and the result is that there were many unsatisfied customers. And then in the late 80s, some brilliant person came up with a revenue sharing model where the video store was able to buy the videos for $4 from the distributor and then share in the each transaction a fraction of the rental charge. So you had a revenue sharing arrangement replace this purchase and selling arrangement. So now the store owner had no reason to economize on videos. He wanted as many as he could. The store owner was better off, the distributor was better off, the user was better off. And some economists, Julie Mortimer, Dana and Spear, have documented this in nice papers. What allowed this to happen was, in fact, an advance in the information technology. There were barcodes that you could scan. There was a cash register. They record everything. And then in the middle of the night, it would call up the warehouse and send in a record of transactions. Just like James Ritty's saloon, they could go over that record of transactions and verify that everybody was getting the appropriate share and verify the correctness, the contractual performance, really on a daily basis. So now we come up to the present, the 2000s, and talk about incentives in online advertising, where what happens there is there's a kind of a misalignment of incentives in any kind of advertising, because the publisher, the person who has the content, has space to put an ad. That's true whether it's TV, whether it's magazine, whether it's online, whatever. They've got some space where they can stick an ad. And of course, they want to sell that space to the highest bidder. The advertiser, on the other hand, doesn't directly care about the ad impressions, doesn't necessarily directly care about how many people see his ad, but they care about how many clicks they get, how many people go to their store, whether it's an online store, whether it's a walk-in store. And ultimately, of course, they care about the sales they make and the profit they make. So fundamentally, the publisher wants to sell impressions, but the advertiser wants to buy clicks. So you've got to align these two different incentives. And it's a little bit like somebody who wants to sell something in euros and somebody else wants to pay in dollars. So what do you need to make it work? You need an exchange rate, okay? And in this case, exchange rate online is called a click-through rate, because you can look at the value per click, how much it's worth to the advertiser to get that click, and then times the clicks per impression, how many clicks that a particular ad gets each time it's shown, and that can allow you to convert the value per click to value per impression. So what you have to do is just calculate the click-through rate just like you'd estimate an exchange rate in other circumstances. Now, in this case, it's a huge statistical machine learning problem. It was nice that you mentioned Dan McFadden. This is a logistic regression with 1 trillion observations and hundreds of millions of explanatory variables. You can imagine it's not solved by matrix inversion, but it is quite an impressive problem in machine learning. And coming out with the right exchange rates is, of course, a very useful competitive advantage. And it aligns the incentives of the publisher, who wants to sell the impression, the advertiser, who wants to buy the click, or in fact the conversion, and then the user, who wants to see relevant ads, which is also part of the entire system. And then just as a footnote, there's also a revenue sharing model there, where every time somebody clicks on the ad, the revenue is shared between the publisher and the ad network provided, and you have the ad network provider, and so you have the same kind of accounting problem that I described earlier. So you have a double example of computer-mediated transactions in that case. So just to drive this home a little bit, let me give you an example. This is actually one of the examples I put on the Google blog. You think of two advertisers, Joe's Jets and Moe's Models. They both want to buy a keyword jet airplane. So somebody types in a query about jet airplane, they want their ad to come up, but suppose there's only space for one of them. So Joe, who sells the jets, he's willing to pay a lot because he has a very high profit margin and those jets sell for a lot. But the problem is not very many people can afford a jet. I mean, Larry and Sergey could afford a jet, but they've already got one, so there isn't much of a market there. On the other hand, you look at Moe's Models. He sells model airplanes. They sell for $25 or something, and he doesn't make very much money per sale, but he gets a lot of clicks. So which ad do you want to put there? The one with a high value and few sales, or the one with more sales and low value? Well, you want to compute the revenue, right? What matters is the revenue. So you look at the expected revenue that you would get from the high price, low volume versus the low price, high volume. And so to figure out which ad should be shown or who's going to win that particular auction, you have to be able to estimate how many clicks per impression the ads are going to get. And so that's what the service, the ad network, provides. And if you look at all the major search engines or selling search engine advertising, a critical part of their business is to be able to estimate those click-through rates so they can show the right ads at the right time. Now, furthermore, this kind of computer-mediated transactions, once you have the computer in the middle of the transaction, you can make advertising accountable. So everybody knows the old story of Henry Wanamaker, who said, half of my ad budget is wasted, I just don't know which half. Well, now you can find out which half, because you can link the ad click, the ad impression, back to conversion or actual transaction, at least on a statistical basis, and that allows you to optimize and tune that purchase process. So, of course, this is very easy to do in search advertising, where you have very, very high relevance, since the ads that people see are keyed to their queries. You could do it in contextual advertising, where the ads that people see are keyed to the content on the page, display advertising, mobile advertising. It's a little harder with the TV, print, and radio advertising because you don't have that direct link communication with the user. You don't see the click. You don't necessarily see the actual conversion. But with these other forms of advertising, since they're so highly mediated by the computers, we're able to do the accounting and attribute the conversion or purchase to the actual ad impression or click. So you really reach a kind of solve a Wanamaker's dilemma. Now, the other thing you do is once you've done this, once you're able, in fact, to observe and link together these different aspects of the purchase process, you can study the data for patterns. You can do various kinds of econometric analysis. So, for example, suppose you had advertisers who were trying to sell something, and they might be interested in buying the keyword diamond, singular, or they might buy the keyword diamonds, plural. And the question is, which of those would result in more purchases, in fact? Which is the more commercial word? Well, it turns out the answer is diamonds. Diamonds is about 20% more costly than diamond. Why? Because if your kid is writing a report on forms of carbon, they'll search for diamond, and if you're thinking about getting engaged, you'll search for diamonds, right? So plurals and generals signify this more commercial level of activity, and so they sell at a premium in these AdWord auctions. You can look at how clicks vary over time of day. I remember the Labor Department did a study a few years ago about whether people were working more at home, and it turns out, I believe the conclusion was they were working more at home, but they were also doing leisure activities more at work. And if you look at Google search activity, you can see that very, very clearly, that there's a lot of online shopping takes place around 11 o'clock in the morning, just like most telephone calls and other things. And you can use this to build predictive and causal models. So you can try to formulate a model that indicates what the probability of a purchase is given an ad click, et cetera, et cetera. So this would be familiar to anybody here who's done econometrics. But the really beautiful thing about it is you don't have to stop there. In fact, what you can do is you can actually do experiments. So there's one of our researchers at Google Labs who's doing some of these experiments, and you can do very nice controlled experiments. So in fact, last year on the search side at Google, they ran 6,000 experiments, 6,000 experiments. And on the ad side, they ran another 4,000 or 5,000 experiments. So there were probably 10,000 or 11,000 experiments that were being run at Google, and roughly 500 improvements were made to the search algorithm because of those experiments. And what you do, basically, is you just take 1% of the traffic, or 0.5% or 2%, and you divert it to the new algorithm, and then you compare the performance of the new algorithm to the old algorithm using various performance metrics. So the beautiful thing about it is you can kind of explore the space using statistical analysis of one sort or another, but once you come up with a reasonable hypothesis, you can actually implement the hypothesis, see what happens, and then improve the system. So you move from a 1% experiment to 2% experiment, a 5%, 10%, and then you run it all the way up and deploy the application. So in fact, the Japanese had this term Kaizen, which was very popular in the 80s. It referred to continual improvement of the production process. So you would take the production process and continually fine-tune it and improve it. But now you have product Kaizen, because if you have a software product, particularly a website, it can evolve in real time. And so the Google, or for that matter, the Bing that you used 2 weeks ago is different than the Bing you used yesterday, and it'll be different from the one that you're using tomorrow. Because, in fact, those products are continuously evolving and continuously improving, because you have this continual controlled experiments that are going on. And ultimately, when you come down to make these decisions, you have this choice between relying on data or relying on hippos. And what's a hippo? Hippo is a highly paid person's opinion. And even if the highly paid people are highly paid for a reason, namely, suppose they have good opinions, you don't really want them sitting around and debating whether the ad background should be yellow or green, or whether the font should be this or that, or what the spacing should be in the web page, or what the details of the algorithm should be. What you want to do is you want the highly paid people to say, go run an experiment and report back with the results, and we'll deploy the feature that ends up performing best. And that's really the model that I think we're going to see more and more in the future, is you're going to try to get rid of these highly paid people's opinions and substitute data to try to make more informed choices. Another thing that you can do with computers is you have this mass customization where the transactions can be optimized at an individual level. So we see this in purchases. You go to Amazon, it tells you people who bought this also bought that, or how you might be interested in this book. You see this in searches where you can have personalized searches that are keyed to the kinds of searches you've done recently, social interaction on Facebook, all sorts of cases where you can highly customize the interaction with the service provider because there's a computer in the middle there that's able to capture the history of your interactions and then assign or provide you with services that are keyed to your individual interests. So, in fact, it's not commonly known, but when you look at a web page, if you go look at the New York Times or the Wall Street Journal or any online content provider, that web page is assembled dynamically just for you. Those ads are stuck in there at the time the web page is assembled. There could be 3 different ad networks, 3 or 4 different ad networks. It could be several different pieces of content, and it's all pulled together at the time the ad is being served. So just try it sometime, look at what's going on. That page is assembled for you, and it can be, in fact, customized or personalized to your particular interest. Now, of course, this raises the issue of privacy. You've got the benefits of personalization. You've got the potential costs of privacy. But as an economist, I look at this problem and I say, well, those aren't really diametrically opposed interests. If you think about a price, somebody wants a high price, the other side of the transaction wants a low price. That's a diametrically opposed interest. But in this case, what happens is the provider is trying to give better service to the users, and the unintended uses are security breaches of one form or another. And so providing better security, information, transparency, and user control can go a long way in aligning interests. And I think when you go to these services, you have to ask, well, what are the benefits? What are the costs? And in many ways, I think there are attractive trade-offs that can be made to provide better service while still respecting privacy in a serious way. Now, up until now, I've talked mostly about advertising. But advertising is just the beginning because these kinds of computer-mediated transactions allow for other kinds of optimization, not just the buying and selling transactions I've been talking about so far, but all sorts of logistic optimization and customer feedback, product design, recommender systems. I mean, there's a long list of things where you can improve the processes across the board. And what I want to talk about next for the remainder of the time is worker-to-worker transactions, namely the organization of work. And to do that, I also want to use a historic example, as an example from Paul David. In fact, he talked about this exactly 10 years ago, or almost 10 years ago, at the AEA meeting on productivity of electricity. And he described the evolution of the factory. So back in the 1880s, factories were powered by water wheels, and the way it worked is there was a shaft down the center of the factory, all the machinery connected to that central shaft, and the machinery tended to be clustered by type. So you'd have all the saws in one place and the drills in another place and the lathes somewhere else because, after all, if you ran a drill, you like to talk about drills with the other guys. And if you ran a lathe, you talked about lathes. It's kind of like labor economists and trade economists. You know, they like to talk about their work. And you can then carry the work around from station to station to get it manufactured. Well, along comes steam engines. They connected that onto the shaft. Along comes electric motors. They connected that on the shaft. Then the electric motor got to be smaller, and they put the electric motors on each piece of equipment, but they still kept them organized the same way because that's how you do it, right? That's the way you design a factory. You put all the lathes one place, all the saws the other place. We've always done it this way. And as Paul David shows, it was really Henry Ford and the assembly line that offered the breakthrough. Instead of putting all the equipment where it had normally been, you try to arrange the equipment in a way that most facilitated getting the work done. So you could arrange the assembly line that allowed you to put the machine where it was most useful, not where it always had been. So that's a little story about mechanical production in the sort of 1910. But I think you could do the same thing for knowledge workflow. So back in 1909, you were worried about optimizing the flow of physical product across the factory floor, and how could you use technology to do that most effectively. But now, In the 2000s, in 2009, well, you wanted to optimize the flow of ideas through the organization. And how do you do that? You do the same sorts of things. You can do this separation, distribution, and optimization of tasks. So you can have multi-author documents, collaborative computing of one sort or another, do your version tracking and control. And you can do that within the organization, not just in one physical position, but you can actually do that at all locations once you've got the data available in the database. So some of you have probably seen a McKinsey presentation, right? They have these gorgeous PowerPoint slides. And I said, how do you get such nice slides? So it took me 2 beers to find out. But finally they confessed. What happened is they'd do their presentation, put it together, and then in the evening they'd send it off by email to Bangalore, and they'd come back the next morning, they'd have a beautiful presentation. So what a great service. You know, what you've done is you can outsource that specialized task. And if you think about it, everybody knows about Adam Smith's pin factory for assembling mechanical work, where you can do the same thing with knowledge work products. You can take those and do this kind of specialization optimization, not only within the organization or within your particular location, but potentially globally. And it's all enabled by cloud computing. So you have this evolution of computing that we've all seen and loved, the mainframe to the network workstation to the personal computer and network computing. So what happens is with the cloud computing, you have direct access. The data lives in the cloud. You can store once and you can read it anywhere, write anywhere using the web, access it from any device at any time by any authorized user. So it means you can increase the productivity of knowledge work now in this decade, in this century, the same way that they increased the flow of physical labor 100 years ago. So let me extend Paul David's example of how factory production worked to something that's relevant to us all here today, namely how do we produce documents. So think about the old days. You dictated a document to a stenographer. It was typewritten. Maybe there were carbon copies that were circulated for comment. There were notes scribbled in margins. There was cutting, there was pasting, and somehow that final document got assembled. Now, there were some productivity enhancements. In the 20th century, we saw whiteout, we saw Post-it notes, we saw other ways to make this process work a little more smoothly. When the personal computer came along, it became yet easier. You could produce the copy of the document, circulate it via email or file transfer for comments, and then assemble all those different pieces into the final piece of work that you wanted to produce. But nowadays, we have a much better model. Instead of circulating the document to a bunch of people, there's one master copy of the document that lives in the cloud, that is some data center on the internet, and that document can be accessed anytime, from anywhere, on any device by any authorized user. And so that means that all of these comments and notes and collaboration, version control, checkpoints, document restore, all those capabilities have now been made much, much easier, and you can produce the final piece of knowledge work in a much more efficient and much more controlled way than you could by using the old technology of circulating documents via email. So what it means, I think, is that the barriers to entry for online businesses have really been dramatically reduced, because what was previously a fixed cost, having to assemble the infrastructure and the knowledge. The important part is the knowledge to keep that infrastructure all running. First you had to assemble that, and then you could build your business on top of it. That's the way things were 10 years ago. But now you can purchase computation in a data center, storage on demand from Amazon, a development environment, and database access, all from cloud computing providers. And it's all priced on a variable cost basis. So instead of having to get the fixed cost to enter the business, you can purchase the required infrastructure and the required knowledge and the required operation to keep your business scaled up as your revenue grows. And I think what that does, to circle back to the beginning of the talk, is it really pushes this combinatorial innovation to a new level, because not only can you combine the parts to create the prototype or do the innovation, but you can now actually do the deployment. It's like being able to buy a factory in modular pieces and assemble your product in a way that was just not feasible previously. So in my view, this fosters a whole burst of creative activity. And one of the things it leads to, which I kind of like, it's a term I thought I coined, but then I Googled it and found out that other people had used it, micro-multinationals. And the idea there is that, you think about it, a small and medium-sized enterprise has access to communication infrastructure that only the biggest companies could afford 10 or 15 years ago, and for virtually nothing. You have voice over IP, you have email, you have wikis, you have docs, you have all these services allow you to coordinate activity across the across distance, so you don't have to rely on coordinating activity only in one particular physical location. So some friends of mine at the school that Bob mentioned, we had several people went off and became entrepreneurs, and many of them are, in fact, micro-multinationals. I ran across a friend, said, "What are you doing these days?" She says, "I have a company." I said, "Where's your company?" She says, "I had 4 people in San Francisco, 2 people in the Czech Republic, and 3 people in New Delhi. And they work around the clock because when they end up closing down in San Francisco, the work is just sent over to India. It's picked up there, and you have this 24-hour work cycle." And her business was, in fact, born international. It was international from the beginning, created by a group of students who'd studied together. And when they dispersed to their home country, they were able to, in fact, continue to communicate in a much more easy way than had been available a decade ago, and they were able, in fact, to engage in productive activity. So in my view, this is really just the beginning. I think there's a huge burst of productivity that's going to come from this availability of information technology that allows you to coordinate productive activity, not just internally, but externally and globally, and we're only at the beginning. So thank you very much for your time. So we have a few minutes for questions. I'm acutely aware that I'm standing between you and your cocktail, so we'll try to limit this. Yes? Right. So the question was, what about concentration? Because cloud computing can be done by very large firms, and will you end up with a concentration in that industry, even though you might get a lot of innovative small firm activity that's supported by it? Well, I think it's kind of an example of book publishing, because it used to be 20 years ago, publishers printed their own books, and then they realized this was it's a very capital-intensive operation. So it made much more sense just to have a few people who specialized in the book production, and then you had all of the publishers that outsourced their work to the same place. And you could do pretty much the same thing with this kind of cloud computing infrastructure that I'm talking about. The one thing that I think is interesting is people are very concerned about proprietary standards and lock-in. So there's a lot of move to make the standards in these cloud computing facilities open to facilitate switching. And indeed, if you look at it, it's kind of natural because mostly they run on Linux, and mostly they run on MySQL, and mostly they run on Python. So they're all using open source technologies in a way that makes it easier to do this switching. So I think it's a potential problem, but I don't think it's actually going to turn into a real problem. Let's see, over here.
Yes, short question. You said that you customize information, every person can get a different set of information. It's going to destroy one of the central competition that's happening.
So the question was, since information could be personalized, won't this destroy competition? Well, I think the issue is, the information itself isn't personalized. It's just there's some idea of what you're looking for. If you're looking for Jaguar and your previous searches have been about cats, they're going to show you one set of results. But if your previous searches have been about cars, they're going to show you another set of results. So indeed, you want to take account of not only the current activity you're doing, but at least the recent past, because then you can provide a better service for people. So I don't think it's going to really have negative consequences. Eric.
Tell us a little bit about the implications for labor demand and what would be exciting or lucrative jobs.
This sounds like a setup, but it's not. No, so I think there's a huge demand for. Oh yeah, repeat the question. Okay, so he said, what's the implication for labor demand of this this picture that I've painted? And I'll repeat something I said a few months ago, that the trick is to be scarce but complementary to something that's ubiquitous and cheap, right? That's what you want to do. So what's ubiquitous and cheap? It's data. There's data everywhere. And what's scarce? Well, it's the analytic ability to understand that data, to make it tell its tale. You know, they say that if you torture the data long enough, it'll confess to anything. Well, what you need is these waterboarding techniques that you can use to analyze this data in a way that really makes it tell its tale. And so I think this is going to be a very, very valuable talent. It's not just the statistics and the econometrics, but it's also the data visualization, it's the database access, it's the experimental design, everything else that comes along with this. Because I've talked about the high-tech businesses, the Googles and the Microsofts of the world, but in fact, the technology is moving further and further down. There's more and more data that's available at a lower and lower level of operation. And everybody is collecting data about their business. It's just some people have been able to bring the talent to exploit that, and other people haven't yet realized that's possible. So I see that as the really important career for the next decade. Bob.
Think back to the 1987 solo computer journey.
Yes.
Why do you think progress in computing and commerce was so slow from 1960 to 1995, so fast since then? Was it simply the marriage of communications and computers? And if so, why did that take so long?
Okay, well, this is really an excellent question. I won't pretend to have an answer. It's a great research topic. I'll repeat the question. The question is, if you look back at Solo's paradox, where we see computers everywhere, but in the productivity statistics, why did it take so long for the computers to really show up in the productivity statistics? And why is it the case that it seems to have shown up so quickly, at least I claim it's shown up quickly, in the examples I've cited? Well, I think it comes down to partly to this cost issue, that information technology was very expensive and it's been getting a lot cheaper, and so you can expand to a much, much broader base. I still think there is some delay in really being able to exploit the riches that we do have available from this data, because the big scarcity is not the data, it's the knowledge of what to do with it that's scarce. And so I think it's going to take some time for these things to happen as well, but at least the groundwork is there. The other thing is, although I do believe that there will be a big boost in knowledge worker productivity, I do have to say that it's going to be very, very hard to measure. Because what do? You count pages, you count citations, you count documents, you count PowerPoint slides. I mean, how is it that you really measure the benefits of having these better ways to produce knowledge? It's going to be a challenge. Yes?
About 5 or 6 years ago, currently, we were talking about promoting tools for building a semantic web.
Mm-hmm.
I'm wondering how far that's gotten.
Yep. Yeah, so the question was about the semantic web. Has that gotten as far as expected? And the answer is no, it hasn't, because it's just a huge, gigantic coordination problem. It's one of the biggest chicken and egg problems around. And it would be nice if it happened, but I think nowadays few people are really holding out a lot of prospect for that to happen soon, because the coordination difficulties are just so great. I think this maybe is a good place to wrap up. So thank you again.
Great. Thank you very much.